Hi, this is Project NotSkyScanner, and this is our 225 final project. The team consists of me, Atish, Sanjeevani, Jasmeher, and Arya, and we're going to talk about our project. So our goal with this project was to analyze the OpenFlights dataset by constructing a graph implementation with our data. For our traversal, we did a breadth-first traversal, and for two algorithms, we did Dijkstra's algorithm and betweener centrality. So betweener centrality helped answer our problem statement. We used it to calculate the centrality score for every node in the graph to find which was the most traffic graph in the dataset. So for our data passing, we use two files, airports.dat and routes.dat. So airports.dat gave us information like the open flights ID, name, latitude, and longitude, and routes.dat gave us the airflow and routes between two airports. We cleaned both of these data sets, and we use them to create an adjacency list implementation. Our graph was weighted with a distance that was calculated using the latitudes and longitudes of each airports along a sphere.
So for our traversal, we did a breadth first traversal. And so the problem that the question that we were trying to answer with this traversal is starting from airport A, which all airports could you go to? And so this would work like a trip planner. And this GIF shows you how a breadth first traversal works. For our first algorithm, we use Dijkstra path between any two airports. We are assuming over here that the shortest path is also the cheapest path between any two airports because it has the smallest distance and the flight has to travel less. And hence, this is like, so we're saying that the shortest path is the cheapest path. And it has a Dijkstra's algorithm has a time complexity of E log B, where E is edges and B is the nodes of the graph.
For our next algorithm, we chose betweener centrality. And so we used this to calculate which is the busiest airport, which was our main problem statement. This will allow the users of our program to choose which airport to go to, considering whether they want more flight timings, more choices in flights, or whether they want to miss a busier airport. So Dijkstra's will help us in implementing this algorithm. And so it's run between every two possible nodes in the graph. And so this will be stored in a vector, and each time this node appears, the frequency is incremented by 1, which will calculate the between centrality of each node.
So the results of BFS and Dijkstra's, they're dependent on the user's input, and while we did use the data set, so ultimately this is meant for the user's benefit. And our results on running the betweener centrality algorithm suggested that the airport with the highest centrality score, so the busiest airport, was the Tokyo Haneda Airport, where Ariel traveled to, and that's the photo from there, his recent journey. And in short, we use 3 different algorithms in our project. We use BFS to traverse the graph to act as sort of a trip planner, Dijkstra's to find the shortest path between any two nodes, and betweener centrality is sort of an additional feature which will rank airports according to how many shortest paths do they feature in, and it will tell you which are some of the busiest airports, which you can either travel to or avoid. So for future, this project could probably add some improvements about user price data and flight time, so it's more accessible in this. Thank you so much for sitting through this presentation. I hope you liked it. We had a great time working on it together as a team. And thank you, Professor Evans Thanks, Brad, and thank you, Professor Ramires, too. Class was a lot of fun. And we did use some references for this project, which is listed over here, and everything else has been committed to our GitHub repository and everything. Thank you.
Thank you.
Yeah.